Thank you, Jaya Kumar, for the introduction. I want to really, well, first and foremost, anybody who's joining, please mute your mic. That'd be great. Second, I'm going to try to get through some of these slides. Yeah, somebody's, there we go. Second, I'm going to try to get through these slides fairly quickly to open up to questions. And before I even start, you know, we live in very interesting times, and I hope that everybody is safe and healthy. I'm going to share my screen here. Let's see. Hopefully everybody can see that. So let's go through some of this. Let's see. All right. So there's this thing called space situational awareness. We're going to talk about it. We're going to talk about why we need it, what it is, how this can be done. And one of the things that I like to start off with is just to tell everybody, you know, before you think about human-made or anthropogenic objects in space, before you have that, you have a space environment, and the space environment is extremely dynamic. And what I mean by that is that you have the sun doing lots of stuff, you have gravity field, you have micrometeoroids. It's a very dynamic environment, even if you didn't have these anthropogenic space objects in it. But once you have these objects in that environment, then the question is, how does that environment interact with these anthropogenic space objects? How does it influence their motion? How does it influence their behavior if they're operational? And so we'll talk a little bit about that. So that is still not something that is completely known, completely understood. So that's still a problem that we have to deal with. And then above and beyond that, we also have to consider threats in space. And there are threats that are real. So what I mean by threat, and I'm going to be very, accurate with this, is to say that between any two entities, if one entity has the intent, the opportunity, and the capability to cause harm or disrupt or interfere with the other entity, then that's considered a threat. Again, intent, opportunity, and capability to disrupt, cause harm, interfere, that's what I'm calling a threat. And a hazard is just not unintentional, no intent, but still with the opportunity and the capability to cause harm and disrupt. So hazards are things that don't have intent, hazards are unintentional, and threats are intentional for our purposes here. So what should things like space situational awareness provide? First, it needs to make the domain more transparent. We need to know, what's there, who does it belong to, maybe even perhaps, what can it do, that sort of thing, as much as possible. We also need to develop a body of evidence to hold people accountable for their behaviors in space. I would say that by and large, we don't have, we certainly don't have a global mechanism to do this, so that is an issue. And then we need to try to make the domain more predictable. So predictability isn't just in the physics, not just the physics about how things move or propagate in the space domain, but also given a common scenario, two objects that are going to come within, say, 50 meters of each other, how are these objects, if they're both controlled by different, maybe companies or even countries, can we predict what they're going to do when they come close to each other? Maybe a US satellite and a Canadian satellite are going to have some given predicted behavior, but a US satellite and a Russian satellite might have different behavior. So we need to be able to understand that there is a geopolitical and cultural aspect to behavior, and that needs to be folded into our ability to predict, what any given scenario moving into the future. Essential ingredients, I would say, for success. Time and time again during my travels, I've heard that people would like to have some system that isn't completely owned and operated by a single country or entity. You know, I think most people around the globe are a bit allergic to the, you know, Lord of the Rings, one ring to rule them all kind of method of doing stuff. And so anyway, so absolutely, I think that, you know, having some sort of international independent mechanism, maybe even a consortium of companies and research institutions and that sort of stuff that could all contribute to the ability to do this monitoring and this quantification and assessment of behaviors. We need sustainability metrics, things like a space traffic footprint, like a carbon footprint analog, but think of the space traffic footprint as the burden that any given anthropogenic space object imposes on the safety and sustainability of anything else. When I get into my car and as soon as I turn on the key and I'm about to leave my house, I am now a burden to pedestrians and other drivers on the road. Even if they see me and see where I'm at exactly, they still have to take my possible actions into account for their own safety. And so that's what the space traffic footprint needs to be, is this sort of idea of a burden that any given object imposes on the rest of the domain and the environment and operations and whatnot. The European Space Agency some time ago came up with this idea of like, you know, orbit capacity. I would like to underscore that and say, you know, from ecological sustainability ideas, the idea of the carrying capacity of a given environment, I think is critical if we want to be able to successfully manage the space domain. So quantifying what this orbital carrying capacity would be good, because then we could predict when that capacity might be saturated. We can engage in behaviors that give capacity back to that. We could regulate, you know, the people that are taking up capacity or entities taking up capacity. And we could even bring in space insurers into that discussion. And then with the World Economic Forum, we're working on something called the Space Sustainability Rating, which would be a way to incentivize sustainable behaviors from launchers and operators. And so we've been doing that for about a year now. And so the European Space Agency, MIT, Space Enabled, Bryce Technologies, and ourselves at UT Austin. And you know, we do have some ideas of guidelines, and people have been developing standards, ISO, and these sorts of things. So it's not that the community hasn't been asleep. People have been busy for a long time, but we'll see what maybe some of the hindrances are. It's not easy to implement these things. Certainly, one of the notions that we have in terms of, okay, so no kidding, how do we actually get into the business of observing things on orbit and space, understanding these things, helping ourselves make decisions and taking actions? So some time ago, this person, John Boyd, had this, he probably borrowed from other areas, but came up with this thing that's called OODA, which stands for Observe, Orient, Decide, and Act. And these are just general steps that need to take place in order to complete this kind of cycle, going from observations all the way to taking actions. And there is no real, you know, except in very few instances, that you can just go from observing to acting. Observations in and of themselves may not be usable. And so it's very critical to take what we observe and transform that into usable data that's been calibrated, that's been conditioned, that's been formatted properly, like all these things. So the orient piece is extremely important information in this activity. And then once you can orient the data, then it's like, okay, now I need to assess what is it that I have, what are my criteria for making some decisions, and then based on that, test hypotheses and come up with some decisions, and then actually act on these things. So one of the things that we try to incorporate in our work is this idea of this OODA loop. How do we go from observations to orienting these things, curating information, conditioning data, that sort of stuff, to what are the decision criteria that I care about? For instance, you know, UN COPOS long-term sustainability guidelines, those would be criteria that you'd want to monitor for compliance or non-compliance, for instance. And then actions, what actions can you take? Maybe for space safety, you're talking about when to make decisions for maneuvering to avoid collisions and these sorts of things. So we have this assumed space object population. I say assumed because we don't track everything. We detect stuff, and some things we don't even detect. So if we go to like the 10 centimeter size, the size of your cell phone and larger, all the way to the space station, we're talking roughly 26,000 or so objects that are being tracked, actively tracked. But then if we go smaller, millimeter size objects, a lot of these things, don't even get detected. And so it's a hypothesized population. Basically, by evaluating samples, we hypothesize what that population might be. And there is inconsistency in what people believe, and we'll talk about beliefs here in a little bit. But needless to say, out of about these 26,000 objects, roughly about 3,000 or so are working, and everything else is garbage in this anthropogenic space object population. And so, yeah, we're talking, 96% of all the stuff that we track is basically debris. Very sad, actually. So how did all this stuff start? I'm just going to show you a quick movie here by Analytical Graphics that just gives you an idea. By the way, the dots are locations only. They're not representing the size of the objects. I've been heavily criticized about dots being too large. So anyway, the dots are just the location. And it just gives you an idea over several years, how this population has been growing. You'll see a little bump there in 2007 with the Chinese ASAT test. 2009, there was an Iridium Cosmos collision. So those are additions, if you will, to that population. And so one question might be, well, when two objects meet, and if they don't meet slowly, if they meet very quickly at a same location, what happens? I can tell you it's not good. But here's another movie from AGI that kind of gives you an idea, simulated, on what happens or what could happen when two satellites meet. And this was a simulation of the collision that happened between Iridium and this Cosmos satellite in 2009. Iridium was working, Cosmos was just dead. And you can kind of see these things meet, and many smaller objects are created, and mostly they keep on traveling kind of in the relative path that they had prior. But now you can kind of see that there's this cloud of more objects, thousands of objects that now engulf part of the orbit and very rapidly distribute themselves around the orbit. So this is definitely part of what the problem is, and we want to try to mitigate these collisions. We want to mitigate this growth of this population as much as possible. All right. So to give you even better news, we have a new space race, and it's commercial. We have planned satellites that are going to be launched here in the next few years, and so this gives you an idea, kind of number of satellites, kind of on the left that you can see on this y-axis, and then orbital altitude. And if all these things were, if all these circles were completely separate from each other, that would be, I guess, easier to manage. But the fact that some of these things overlap means that they're sharing orbital regions or orbital zip codes or neighborhoods. So that has to be something that we need to think about quite carefully in how we manage the situation. One of the things that we've been looking at in terms of principles that can achieve sustainability that maybe we could apply to space is from so-called traditional ecological knowledge or indigenous ecological knowledge. And it turns out that there are indigenous people that for thousands and thousands of years have behaved in ways in scarce environments where they've had to achieve sustainability. They've found ways to do that. And so these principles that you see on this slide come from indigenous people, whether it's maybe some indigenous people in India, Maori in New Zealand, Aborigines, Australia, Inuit, Hawaiians, others. So these are principles, common principles that have been shown, tried and true, that help achieve sustainability. gathering factual observations, developing evidence of relationships between things in a given domain, understanding the carrying capacity of the environment, finding ways to maybe register the information, share, coordinate things, help with the transparency and predictability, understand the types of objects and that each one of these may have different missions and purposes and they should be treated differently. What kind of norms of behavior are we going to basically try to have people subscribe to and that sort of stuff. Methods to prevent things like arm races in outer space and that sort of thing. Understanding cultural relationships to objects. I can tell you that anything related to, the Apollo program for the United States, those are like treasures in space. But to another country like, I don't know, maybe an African country like Nigeria, that level of cultural heritage just isn't there. And it's like, well, that rocket body that's debris. Well, to somebody else, it might be a treasure. So we just need to be very cognizant of these things and how to manage it. So principles or tenets of traditional ecological knowledge. You can kind of think of these in these kind of three spheres. You have ethics, again, norms of behavior, that sort of thing. And we have things that we practice, respect, data sharing, specific techniques that we've learned through trial and error, things that work, things that don't work. And then the knowledge that we cultivate as a result, and how do we make that, as understood as possible, understanding these causal relationships and all that. This is just kind of a picture of tracked objects. I'm going to skip over this because maybe we can get to, I can just show you from the website later. I was telling you about space environment effects and impacts on the anthropogenic space object population. And yeah, I can tell you that we don't fully understand this. And so part of the problem with not fully understanding this is ambiguity. And we'll get to what that ambiguity means. But basically the space environment can cause havoc on these objects, can disrupt operations, can debilitate given on orbit activities. And so we need to understand what are the natural causes, because when an anomaly happens, we want to disambiguate that as much as possible. Yeah, so some goals for successful space situational awareness is we want realistic and quantifiable measures of uncertainty. We don't know everything exactly. And so we need to be able to understand what part of the uncertainty might be systematic or epistemic, as it's formally called. What part of the uncertainty is driven by randomness or aleatory sources? Can we abductively understand things that are going on in space? Meaning, as we get data, start forming hypotheses and testing these things and learn from, evidence-based kind of processes. And, is there a way to uniquely identify and maintain custody or otherwise do like continuous supervision of space activities and space actors? Article 6 of the Outer Space Treaty says those sorts of words, but I can tell you that nobody on the planet is able to continuously supervise and monitor all space activities. And so that is a gap. That is a risk, significant risk. I was telling you about anomaly attribution. So this is just an example of a storm back in 2003 that caused a lot of havoc on objects in space. And people were able to share some information and correlate part of their anomalies to this storm. But in the absence of that, it's very difficult to know whether or not a natural effect or event cause an anomaly to the satellite versus somebody intentionally doing something, right? We often talk about detecting and tracking objects, and I just wanted to give you an example of what the difference is. Detecting is, as you can imagine, simply being able to you have some sensor and you have a signal that's registered. Is there a signal real? Is it spurious? That's an important question to answer. But just because you get a signal doesn't mean that you know what the object is. And so this is an example from the Space Surveillance Telescope before it got shipped to Australia, where it currently is located. And it's a single night's worth of detections. And so the differences in color here from the single night's worth of detections is that the black, the detections that are colored in black are things that were detected and allegedly we know the identity of the object. It correlates or associates to something in our known database, and everything else is unknown. So detecting is insufficient because you can see that there's a lot of stuff that is detected that we have no idea what it is. And that's a problem, because if we want to be able to make the domain transparent, make it predictable, be able to hold people accountable for their behavior, we need to solve this identity crisis in space. Another way to kind of say this is that we have the whole set of events and processes that happen in space. That whole set, as a whole set, is unknowable for a variety of reasons. A subset of everything that happens in space are things that we believe, and there's another subset of things that we measure or evidence. And so where our beliefs and the evidence kind of overlap, that's inferred knowledge. Beliefs that where we don't have evidence are hypothesized knowledge, and things that we have measurements for, but we have no hypotheses for, that's latent knowledge. The knowledge is there, but it's just kind of waiting for us to discover it. You can see these circles fall outside of what's actually possible. And that's because we have beliefs that actually aren't real. We hypothesize things that are actually false. And when we measure, we actually have supposed evidence that is not real as well. Like sensors do generate, register information or put out information that actually, never happened. There was no real signal. It's just spurious data. So we have to be careful with that, very careful. Another thing that we have to be very mindful of are like information categories, and that all information shouldn't be treated the same. And it depends on who owns and controls and manages the information. To some folks, a common set of information might be, this is true, these things are true, but then there could be malinformation where in the hands of somebody else, they might want to put this true thing out there to the public with the intent to harm, right? But then there's like false information, and some people might want to take the false information and with the intent to harm, and that's disinformation. But the false information without the intent is just misinformation. People report things all the time without the intent to cause harm, and it's actually not true stuff. Some people want to hide things purposefully. So we should, in space situational awareness, we need to think about these categories of information, and we need to try to assign labels to categorize these things so we can know what decisions that we make, the decisions that we make in some part are influenced by these different categories. We suffer from confirmation bias, like a lot of other domains. And so, we tend to, once we have a belief and we have a few things that might confirm it, we tend to shut our eyes and our minds to any other evidence that might sway us away from that. And that's what I call, formally confirmation bias. I call it, belief inertia. It's the resistance to change your belief in the presence of evidence that might even suggest that you should. So we need to be allergic to that. We need to, as much as possible, prevent ourselves from doing that, because when we do that, we risk actually making the wrong decision because we don't have the right belief. So what happens when we have a belief and we hold so strong to it and we don't want to accept other evidence? Well, this can happen. Partial information, right? This is a nice example because the cylinder, but it just so happens that you have two beliefs about what this thing is. And it's not that the beliefs are completely false. They're just not completely true. And had these two beliefs been shared with each other, then you could come up with a better picture of what the situation or the event actually is. And so that's what I'm, suggesting, is that we need to be a bit resistant to not allowing other information or other evidence to come into play. A very pragmatic example, if you go to US Space Command and just look at kind of what's available on spacetrack.org, this is like a common space traffic map without the debris that you could see from Space Command. But if you ask, the Russians with their JSC Vimpel catalog, then that's what, you might see. And so these things don't look exactly the same. And part of that is because information is not shared and combined to get a better picture of what's going on up there. Let me give you a better example. maybe even stranger for you, is that we don't even agree on common objects. So here's one object. This case is like flock 1C10 that belongs to planet. And you have 4 opinions of this stuff. You have the opinion of the Department of Defense, the opinion of the owner, the opinion of Leo Labs that commercially track stuff. Let's see, looks like somebody might have their mic open. And you have my own kind of opinion as well. Oh, sorry. Anyway, so the thing is, these opinions can be, inconsistent with each other. And so what's driving the inconsistency? Why are these things not lined up with each other? Like the difference in position here could be, a couple hundred meters, say. But if you try to predict the collision based on this, which one do you predict the collision with? 1, 2, 3, or 4? They're all the same object. They're not in the same place. They actually don't have the same collision risk because they're in different locations, right? So this is part of the issue, is we have inconsistencies. We need to find consensus amongst information. So how can we discover and corroborate this stuff? Definitely multi-source information, multiple hypothesis testing, doing this abductive reasoning that I described, using things like knowledge graphs or ontologies, those sorts of frameworks to try to link disparate sources of information with each other to take advantage of big data science and analytics, fusing physics-based sources with human-based sources, that's hard and soft information fusion, being able to assign kind of the genome, a fingerprint to the actual information itself with metadata, that's the information provenance, and being able to do clustering analysis, running interesting queries to see what we can discover about this population. So ontologies is kind of like a fancy way to say we want to describe a domain with semantic linkages and relationships as part of that, gathering this factual knowledge and being able to discover causal relationships amongst things. We want to take advantage of the information, curate it, or represent it in a way that is easy to interpret and do analysis. So on the far right of this, you have these 3 layers, raw sources of information on the bottom. The middle layer is this knowledge graph database, and the top layer is apps. So yeah, so what we want to do is we want to take all this information that may not be inherently usable, map that into this lingua franca, which is this middle layer, this is the knowledge graph, and then have applications from the user community that can query and do interesting things with it. And things like feature extraction, clustering, being able to associate things, basically a way to go from data to discovery is what's facilitated by this kind of framework. And applying different kind of pattern recognition and clustering analysis to try to discover these causal relationships in the community. So monitoring this anthropogenic space object behavior. Are there threats in space? How do we infer intent? That's a tough cookie. There's no sensor that I know of that is an intent meter. So that's difficult. What is abnormal behavior? Should we be, how should we feel about behavior that we don't understand? What do we do about it? What are the default actions? How do we minimize misconceptions, misinterpretations, miscommunications? Cultural competency, cultural relevance, I think is something we need to bring to the table there. How do we protect ourselves and the environment at the same time? How do we incentivize behaviors that lead to increased safety, security, and sustainability? How do we improve and motivate compliance? Can we use citizen science to do this stuff? These are very interesting questions. One of the things that we did as an example is we looked at how do we monitor for things like compliance. We looked at just the geodisposal compliance, and we just created basically an application that's what it does. And it just kind of shows you, if you take the information, create schema and ontologies like what you see here on the right, and actually organize information this way, which is the orient part of the OODA loop, then you can actually do some analysis in the decide thing and then figure out how to act in that last phase. So anyway, there's just a website there that gives people this idea. So I think way ahead, the work that we do, it has to result in these 3 things: transparency, accountability, and predictability. We have to recognize that the domain near Earth space is a finite resource. It is a commons in that sense. And we need to basically map environmental protection narratives to near-Earth space. So just beyond oceans, atmospheres, and climates, we need to include near-Earth space in that. We have to have a way to independently monitor, assess, and quantify anthropogenic space object behavior, corroborate the evidence independently. I'm proposing that we use the tenets of traditional ecological knowledge as a basis or a foundation to achieving space sustainability. Talk to you about a number of technical challenges that still need to be invested in and looked at. The absence of open, accessible evidence and benchmark data set is a significant hindrance to the way ahead. And we need to be allergic to this idea of confirmation bias and not accepting evidence that we didn't generate. So with that, I'd like to just open it up. I'll give it back to Jaya Kumar and then we can take it from there.
Yeah, thank you, Dr. Moriba. It's like wonderful presentation, and we have learned about like how we are tracking the object and to understanding the fundamentals of to space object behavior, like how it can behave in the space. So now it's like a floor is yours. I think like if you have any questions, the participants, they may chat in the box, or maybe they can raise the hands and we can try to. The question is that Moriba, maybe you can see the chat. Maybe some of the questions. I mean, like, does other technologies currently existing to bring back the space debris?
So I'm sorry, are there technologies to clean the debris is the question?
Yes, does the tether technology is currently existing to bring back the space debris? Is there the technology?
Yeah, so I mean, in terms of like tethers, I think there's some people that are considering that. Certainly debris remediation, which is debris removal, has to be part of the answer. But it's not the only answer. And so what I mean by that is that, unfortunately, we as a global community have to accept that our bath water is filthy and it'll never be clean. So we'll never be able to clean the current debris population in its entirety. That's impossible. So we should accept that right now. We will always have to live with objects that we can't detect or track that are hazardous to operations. And so this low-level filth is something we have to accept that we live in. I would say, much like in other areas where we're trying to motivate the eliminating single-use plastics. That's something that, you know, the world should all endeavor in striving for, right? And some people are a lot more forward-leaning in that. We should strive to eliminate single-use anthropogenic space objects or satellites. We should strive to eliminate single-use satellites. This idea of graveyard orbits, that's a bad idea long-term. That's not good. It can't possibly be good to think of having the equivalent of a landfill in space. So that can't be the long-term answer. And so can we make these objects recyclable, reusable, you know, all these sorts of things to eliminate kind of, like I said, single-use satellites. And I think that a lot of people in low Earth orbit are trying to use the natural environment of you know, drag effects that naturally cleanse these things, remove objects, you know, after several years. They're trying to get away with just saying, oh, well, you know, I can have the single-use disposable satellite because, you know, the atmosphere is going to just take care of that. So we need to be very careful with that as well.
Yeah, that's a great. So here the question is like how we tackle the small, very small particle debris, even below the micro level, even more dangerous. That will be just a waste. Any comments on it?
Yeah, so the thing is, we can't really do anything about it except try to understand it to shield against it, but there's no removing it. So there's nothing that we're going to be able to do to remove that. And there's no way that we're ever going to get to the point where we can track it and predict where it's going to be. So this is, you know, the untrackable population can only be understood from a statistical perspective. we care about the whole population of these small pieces, but only in specific instances can we measure the effect of samples from the population, and so we have to make statistical decisions. Through statistical inference, we have to make decisions about how do we shield and that sort of thing. That's the best that we can possibly do.
Yeah, that's a great. Thanks for answer, Moriba. It's like there will be like some kind of a question, like, can we send some object like that decompose in space itself by itself?
Yeah, so I think that's interesting, right? I mean, you have there have been scientists that have been supposedly creating ocean debris eating bacteria, bacteria that eat plastics and that sort of stuff. At least I've heard in the news. I'm not an ocean scientist to know for sure, but yeah, I mean, if there was some way to create these anthropogenic space objects out of some material that the thing is it degrades and it would become what, right? I mean, the thing is energy isn't created or destroyed, it's transformed. So we'd have to think about that carefully.
Yeah, thank you, Moriba. It's like, is there any new material is invented to overcome the space debris problems? Something like that. I think like it's similar.
Yeah, there are people doing material science, metamaterials, these sorts of things. So it remains to be seen.
That's cool. The another question is like, who do you propose to have the overview of monitoring and tracking the satellites and debris?
I think it's ultimately based on the Outer Space Treaty. It is the responsibility of governments to do this sort of thing. But I would want to empower industry, academia, kind of citizen science to augment government capabilities. I'd like for people to, even though legally it's the responsibility of governments, I'd like for regular citizens to step up to the responsibility and say, hey, if I'm going to be somebody who either uses the environment, exploits it for business or whatever, or get some benefit from it, and I have an ability to contribute to the monitoring, then I should.
And the next question is, thanks Moriba. This next question is like, is there any way to send a huge, powerful magnetic satellite to collect all debris?
Yeah, the answer is no. The answer is no. Let me just, yeah. So it actually turns out that a lot of the material up there is not magnetic. So the answer is no. It's been thought of, and the answer is no.
And what kind of the technologies like you like to suggest, suggest some to collect the debris? Like it's not the magnet.
I'm sorry?
Apart from the magnet, what kind of the technology can be more efficient?
Yeah, I mean, so Surrey demonstrated like a net and a harpoon. Clearly that wouldn't work for everything. Again, there's no one size to rule them all sort of Lord of the Rings way to do stuff. I know that Clear Space, they're going to be rendezvousing with the Vespa payload adapter in 2025. That has a different mechanism. Astroscale has something different to do their orbital sweeping. So there's a variety of things, but magnet, I don't think magnet's one of them.
Yeah, that's great, and it's like a very realistic answer, is that. And here the next question is like, what about the CS lunar mission, and your comments on CS lunar mission, and
yeah,
there will be a lot of debris missions.
Yeah, so I've seen some of the plans for Artemis and getting folks to the moon again and all that. It definitely seems like a huge footprint in terms of materials and all these things. I think NASA, Artemis, with the Artemis Accords, they want to minimize debris. They want to mitigate it. It's one of the Artemis Accords specifically spells that out, so that's good. The thing that I don't see, right, is I don't see how do you know who complies and who doesn't. Like that's the thing that's still missing. Is if you wanna enforce any of this stuff, you have to make it knowledgeable, and if you want to make it known, then you have to measure it, and it's back to the measurements. So I see that we talk about wanting to do all this cool stuff and behave these ways, except that there's no agreed upon independent way to do the monitoring, verification, and assessment. And I think that's like one of the biggest holes in all this stuff.
Thanks, Moriba. Here, the next question is like how the trajectory of space debris is detected.
Yeah, so we do that with physical sensors, mostly radars and telescopes. Radars for things that are closer to the Earth, telescopes for things that are further away. And by collecting these data, then we have to come up with astrodynamics algorithms that can try to fit a hypothesis through the data and see which hypotheses tend to be the ones that explain past measurements and help you predict future measurements, to then say that, yes, I believe indeed this is the flight path or the trajectory of debris, because debris doesn't self-report its identity or its location.
Yeah, so what's your comment on like the dangers of thousands of proposed CubeSats, and there will be like the several thousands of the satellite constellations by private and the federal government, the constellations, and how we are going to manage this?
Right. So this is where I think we need to look at traditional ecological knowledge, those principles, and we should manage it following those principles. So I'll start there. But the number of objects doesn't have to be, I don't see that inherently as being the problem. It's all these objects operating in their own way without coordination, without proper planning, without the ability to predict how these things are going to behave. So it's ambiguity, it's uncertainty. Uncertainty is the biggest problem, not the number of objects per se.
Yeah. Thanks, Moriba. It's like, okay, so now how you tackle the situation when we are in the low Earth orbit, especially because there will be like International Space Station is the living form is there, and there are the several millions of already existing rocket bodies. You mean like more potential dangerous places, Leo? So like how we are going to manage it? Like, is that kind of any proposals that we need to, like if
yeah, so I think I'm gonna joke a little bit here, but I think first you start with prayer. Look, there's just a lot that we don't know. We're already taking a significant level of risk. There's this, again, underlying filth that we have to live with. I think, again, we should look at these principles of ecological knowledge to try to achieve this sort of sustainability, and globally work together to do this monitoring and assessment, to come to agreements about some of these things. And then what are the consequences? Are there any consequences for folks that don't follow this stuff? And how do we impose or enforce those sorts of things? So I think that's really where we need to put some effort.
Thanks, Moriba. It's like a wonderful session today. It's like we have learned many things, and thanks for your time and accepting our invitation. And we're glad to discuss with you more. And is there any final? This is the final question. It's like, is there any opportunities to learn about the space object tracking detection things? And is there allowed to open communities? Like some of them are working as like individual professionals, or maybe something like they are not from the college, or maybe they may be independently doing. Is there any opportunity to take part in your Astrograph project?
Yeah, so right now on the educational level, we're trying to explore coursework and that sort of stuff within multiple kind of degree programs, and looking at maybe creating certificates. Every year we have a space traffic management conference here at UT. It's probably going to be virtual. It's going to be like around January 26th. So just keep an eye out on LinkedIn and these sorts of things when we put notice out there. But that would be an example of something that you could definitely call into to hear to some of these experts and whatnot talk about these problems, and be a participant in providing your own voice in your opinions about how people are using space and all that other stuff.
Thanks, Moriba. It's like you recently have signed an MOU with the Indian Space Organization to the space activities. I think it's like it is open for the international platform. I believe this will be the exciting thing. And we are ending the session with the last question is like, can we artificial intelligence can be incorporated to clean up space debris in any certain extent, something like.
Yeah, so I think artificial intelligence, machine learning, I think these things can be very useful. They're only as useful as the data that you feed into these things. So to me, it's like AI and ML do very well, and basically they assume that tomorrow looks like today. So if the version of today that you feed it is not so good and it's not diverse, then its prediction of tomorrow is not going to be good. So you need to feed it lots of todays and lots of information about the todays, and in that measure, it'll be a decent predictor of what tomorrow might be. So yeah, I think that there's a role for AI and ML, but only in the hands of people that really know how to use it, and only with a rich enough set of data to make it meaningful.
Thank you, thanks Moriba for a wonderful session. I think we have ended up today. Comment from you. Is there any openings, or like for example, like international student internship in your laboratory or something like that?
No, not at this time, but just kind of keep an eye out on social media.
Okay, that's cool. Thanks, Moriba, and thanks for joining. Everyone is like they're from the. I mean, like we are like globally we connected and virtually connected today. It's like we have, like we have to try to. It's like our social responsibility. Like we have to keep our planet safe, and also we have to keep things very cleaner, and also something want to make it again great again. So thanks for all for joining today, and this will be the recorded sessions. It will be available in YouTube channel as well. So maybe if someone has missed the thing, so we can watch it. And thanks, Moriba. Thanks for a wonderful time, and we are very happy and appreciated. Thank you. Thanks a lot.
All right. Cheers, everybody. Thank you.
Cheers.